Hi, in this video we will study about one-way ANOVA. So consider different samples from different population. So with their means as say x1 bar, x2 bar and x3 bar and so on. So we assume that all are taken from the normal population. So here in the null hypothesis in one-way ANOVA is nothing but all the means are equal. So we have certain assumptions of ANOVA. So ANOVA means analysis of variance. So each population is having normal distribution and the population from which the samples have drawn have equal variances, and each sample is drawn randomly and they are independent. So these are the assumptions. So before we start any problem in one-way ANOVA, we have to set the null hypothesis. So these are always classified according to one factor or the criteria we say. For example, you see here fertilizer 1, fertilizer 2, fertilizer 3. This is given. So I am comparing only one factor, whether fertilizer 1, 2 or 3. So I am not comparing in between the samples. So if I compare in between these samples row wise as well as column wise, then we call it as a two-way ANOVA. So see this example. 3 types of fertilizers are used on 3 groups of plants for 5 weeks. So we want to check if there is a difference in the mean growth of each group. So they want to know the difference only in the mean growth of each group, and they don't want to check in between this first set of sample and the second set of samples. So this is one-way ANOVA. So we are checking only the difference between the columns. So they have asked to apply a one-way ANOVA at 0.05% significant level, 0.05, which is nothing but 5% significant level. So when you are finding the values from the table, you have to find the 5% significant level to compare the values. So how to fix the null hypothesis H0? So I am assuming that the sample 1 is equal to mean sample is equal to mean sample 3. So this is my null hypothesis. So all the means are equal. So let us solve this. So first what you have to do is, so it's given row wise, right? So we are going to write it column wise. It's easy for it. If you want, you can write it row wise and calculate. And we are calculating the total sum of these values, that is 6 plus 8 plus 4 plus 5 plus 3 plus 4, it's 30. Similarly, the sum of all these values is 54 and the last sum value is 60. So if we add these two values, that is 30, 54 and 60, you will get 144. This is the total. To find the correction factor, we will write correction factor is nothing but t square by n. Okay, t square is nothing but this total t. So this is 144 the whole square, by n is nothing but the number of values. Number of values given. So how many values are given? 1, 2, 3. 3 values. How many columns? 3, 4, 5, 6. So 6 3s are 18 values are given. So if you want, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 values are given. So your correction factor is always t square by n. We are ready with the correction factor. Now step 1, which is over, to find the correction factor. And step 2 is we are going to find the sum of squares. What is given? In the question they have given 6. So 6 square 36. And the second value is 8. So 8 square 64. Third value 4. 4 square 16. Fourth value 5. 5 square 25. The next value 3. 3 square 9. And then these are the values I am talking about. That is these 6 we done, 8, 4, 5, 3 and last 4. So we get 4 square, that is 16. Like that we are squaring all the values and we are adding up all the squares. That is 36 plus 64 plus 16 plus 25 plus 9 plus 16 is equal to 166. Similarly, square all the values and add. Your second column, if you see, 8. So 8 square plus 12 square plus 9 square plus 11 square plus 6 square plus 8 square. This will give you this total, that is 516. Similarly, square and add, you will get 628. If you add all these things, you will get 1304, which is nothing but your sum of squares. This we call it as SST. So total sum of squares. So now, this is sum of squares, and now you have to find SST. And the formula for SST is the sum of squares minus correction factor. Okay. So this is the sum of squares minus correction factor is the formula. So what do you mean by SST? Total sum of squares. So this is nothing but whatever sum we have done minus the correction factor that we found in step 1, right? We have to subtract this. So this will give you SST. Keep this as it is. Now step 3, we are going to find SSC. So SSC is nothing but already you have added all the values, right? For example, this column A. Column A is sum is 30. Column B sum is 54. Column C sum is 60. We are going to square it. I've written the formula. So SSC is A square by NA. NA means number of values in that particular column. B square by NB, C square by NC. How many values are there in this given question column? 1, 2, 3, 4, 5, 6. Each column we have 6 values. Total, what we calculated in the beginning, total is total number of values. Now, each column, fertilizer 1 has 6 entries. So, what we are going to do? Add all these values. This is 30. So, 30 square divided by 6. Similarly, second value we saw is adding all the values. We got 54. Again, in this column also same 6 set of values. So, 54 square by 6. And then the last column is 60 square by 6. So, this is your sum of squares between the columns. So, sum of squares between the columns is nothing but 84. So, now you got SSC. So, now we are ready with all the values. So, SSC we got. Now, we have to find sum of the total sum of squares due to error. So, SSE is nothing but total sum of squares due to error. So, to find this, the formula is SST minus SSC. So, SST what we have got? 152 already we have got. And SSC is 84. 152 minus 84 we got 68, which is SSE. Now your table is ready. You are going to enter the values over here. And now finally the last step, that is the result. So in this we have this tabular column. The first one is source of variation. So what is the source of variation? Between the sample and within the sample. And then degrees of freedom. Degrees of freedom, how we will calculate the degrees of freedom? That is, we have V1 and V2. You just go and check how many values, set of values they have given. So they have given 3 columns in this question. That is fertilizer 1 for first column, fertilizer 2 for second column, and fertilizer 3 for the third column. So I will write V1 is 3 minus 1, which is 2. So this is your first degree of freedom. Similarly, we have V2. And V2 is nothing but N minus C. That is, how many values are given? 18 values are given total, minus how many columns are there? 3 columns, that is N minus 3, that is 15 is your V2. So now we are going to write down the values. Okay, that is the sum of squares. What is the sum of squares between the samples? That is, your SSC is nothing but 84. And this is the error within the sample, that is SSE is nothing but what we got as SSE. Here we have 68. So we are writing these 2 values here. So now this is done. Now mean sum of squares means, that is MSC means this is SSC by V1. That is your 84 by your V1 is 2, which is nothing but 42. And then your mean sum of squares in the error is nothing but this by this, that's it. SSE by V2, that is equal to 68 by V2 is 15. So if you calculate 68 by 15, we get 4.53. So we will write 4.5. Okay. So now we are going to calculate the final F ratio. So your F ratio is nothing but okay, so your F ratio is nothing but this value 42 divided by 4.5. That is, the formula is MSC by MSE. If you write 4.533, you will get 9.2 something, or if you write truncate this as 4.5, you will get 9.3. So whatever it is. So this value is your F ratio, say 9.3. Now I have to check whether it is greater or lesser than your 5% critical value. For what degrees of freedom? We have degrees of freedom V1, V2, that is 2, 15. So you have to check the tabular column where what is the value corresponding to this degrees of freedom V1 and V2 for 5%. So, and this value happens to be 3.68 from the tabular column, your F value. So 9.3, which is greater than 3.68. So if it is always, what we will do, greater means we will reject the null hypothesis. Let me show the tabular column to you. I will attach the picture of the table at the end. Actually, it is 3.88. Anyhow, it is greater than. So how you have to check means, normally in your table here degrees of freedom V1 and V2 will be there. So what is your V2? Your V2 is 15. So here you have to check in the 15th row. Okay. So 15th row, and here 1, 2, like that will be there. Second column you have to check. So what is the corresponding that you have to. So in some tables they will give 5% in the first line, and next line 1%. For example, 15 itself 2 rows will be there. It depends on how they are giving the tabular column. In this question 15th is not there, so very next value we will take it. So it happened to be 3.6 something only, it is there, correct. So 15th row, second column, this value will be there. So this is the corresponding value. Anyhow, your 9.3 is greater than 3.6 something. So we will reject the null hypothesis. So what we conclude, your question is one way apply one way ANOVA, and they are asking you, is there a difference in the mean growth of each group? So what you are, first I concluded that there is no difference, correct? Your null hypothesis is no difference. That is why I am saying that all means are equal. So now I am rejecting the null hypothesis, which implies there is a difference in mean growth. So the same thing if you apply for the calculations for row wise also, then you will be getting two-way ANOVA test. So since we are just comparing the samples, so it is one-way ANOVA. Thank you.